Okay. So, y'all, with chapter seven, one of the things that we're talking about here, y'all, in chapter seven is we're going to talk about trig identities. And in trig identities, y'all, one of the things that we're trying to do is we're trying to figure out how can we write one trigonometric function in terms of another. Or we're going to have some kind of a trig expression on one side, and there's going to be a trig expression on the other side of the equation, and we're going to try to make one side look like the other side, okay? So, y'all, fundamental identities. The first ones we're going to talk about are these fundamental identities, y'all, are things that we call reciprocal identities. So, if you remember, if you're looking for the cotangent of an angle, it's just one divided by the tangent, right? You can take the reciprocal and you'll get that. The secant of an angle is one divided by the cosine, and the cosecant is one divided by the sine, right? We flip it and we find those other. So, remember at the beginning of the semester, we talked about how do we find the sine, the cosine, and the tangent. And then once we knew those three, it was really easy breezy cover girl for us to find the cotangent, the secant, and the cosecant, because all we had to do is take the reciprocal. The other types of identities, y'all, are quotient identities. So there's two quotient identities here. The first one is the tangent angle is equal to the sine of theta divided by the cosine of theta, and the cotangent theta is cosine divided by sine of theta. Okay. Y'all, the Pythagorean identities, the one that a lot of people, and when you're doing trig stuff, the one that a lot of people remember is this guy right here. Sine squared theta plus cosine squared theta is equal to 1. These are also Pythagorean identities. And y'all, I'm going to show you in a minute, to me, the easy way to sort of figure out those identities, okay? And then, y'all, there's something that we call even and odd identities. So the sine of negative theta is equal to the negative sine of theta. The cosine of negative theta is just the cosine of theta, and the tangent of negative theta is the negative tangent of theta. And then again, we can kind of see the same thing happens with the cosecant, the secant, and the cotangent. Okay, so it says, look, we're also going to use alternative forms of the fundamental identities. For example, two other forms of sine squared theta plus cosine squared theta equals 1 are these guys right here. Okay, so y'all, let me show you guys something before I start kind of getting into doing some of the identities. When we were first learning how to find the sine and the cosine of our angles, and I'm going to just kind of draw a very simple picture and say we were in quadrant 1, and this was my x value, and that was my y value, and that was my r value, right? Do you remember when we first kind of started doing this, we used the Pythagorean theorem? And when we used the Pythagorean theorem, didn't we say x squared plus y squared equals r squared? Isn't that kind of how we started off? Okay, so y'all, I want to kind of show you guys something here. If I were to take, I'm going to do this and I'm going to call it step 1. If I were to start off with that Pythagorean theorem, okay, and I were to say, I'm going to divide everything here by r squared, okay? I want to show you something, y'all. If this is x squared over r squared, I'm going to write it like this, x over r squared. If this is y squared over r squared, I'm going to write it as y over r squared. R squared divided by r squared, y'all, is just 1. Does anybody remember when we talked about the cosine of our angle, the sine of our angle, all that kind of thing? What trig function did we define as x over r? Does anyone remember? Cosine, right? So look, y'all, this is cosine squared theta. What did we define as y over r? Anyone remember? Sine, right? Look, check it out. Sine squared theta is equal to 1. Y'all, that is my first Pythagorean identity. Okay? Now, I'm going to walk you through another process, y'all. Look, I'm going to kind of scooch over here where I got a little bit of room, and I'm going to call this guy here, y'all, number 2. And I'm going to start with the same Pythagorean theorem that we've been working with. Y'all, the first time we did this process over here in red, we decided, let's divide everything by r squared. Y'all, we have 3 variables here. We have x, we have y, and we have r. And so the first time I said, look, let's divide everything by r squared. Yo, just cause let's divide everything, say by, oh, I don't know, x squared. Okay. And let's see what happens when we do this. Yo, the first time I do this, these guys are going to cancel out. That's going to give me 1. Okay. Y squared over x squared. Yo, I can think about that as y over x all squared. R over x squared, I can think about that as rx all squared. Okay. Now I'm going to go really slow here. Look, I'm going to write 1 plus. Yo, does anyone remember from back in chapter 5 when we first started learning about our trig functions? Which of the trig functions do we define as y over x? Anyone remember? Which one? Tangent, right? Boom. Take a look, y'all. Now we got tangent squared theta. Okay. Let's see, y'all. On the right side, I have r over x all squared. Now, I remember x over r. We just did that right now. Look, we said x over r was the cosine squared. So if it's flipped, if it's the reciprocal, what is the reciprocal of cosine? Secant. Secant squared theta. Y'all, I want to show you something. Look, I'm going to look at that dude right there in blue. I'm going to zoom back over here. And I'm going to look at this guy right here. Boom. Tangent squared theta plus 1 equals secant squared theta. Hey, we just found the other one. So, y'all, the reason I'm telling you this is, again, it's been a minute, y'all, since I taught trig, right? But I remember when I was living up in Austin and I was working at ACC at the community college over there, you know, a lot of my students said, hey, Omar, you know what? This one is really easy for me to remember. I can always remember sine squared plus cosine squared theta equals 1. I tend to forget those. I tend to forget, like, what is the formula? What is the identity? And so what I would tell them is, look, let me do this real quick. Boom. Let's start off with the same Pythagorean theorem that we've been dealing with the entire time. And look, the first time, y'all, we divided by the r squareds. The second time we divided by the x squareds. What do you think I'm going to divide by now? The y squareds. Boom. And when you do that, you don't necessarily have to remember every single Pythagorean identity, because if you know the Pythagorean theorem, you can find those Pythagorean identities pretty easily. So look, y'all, this is going to be x over y squared. That's going to be 1. This is going to be r over y squared. Let's see, x over y. Y'all, y over x, we said that was tangent. So x over y is going to have to be cotangent. Okay. Look right here, y over r, we said was sine. So r over y is going to be what? Cosecant. Boom. And there's my other one right there. And I don't ever really have to remember all 3 of them. Like, I don't have to memorize them. Does that make sense? And then I'm able to kind of find those identities if I need to. Okay. So again, you know, if you could memorize them and you don't have that issue, hey, don't worry. But if you forget, start off with that and divide either by the x squared or the y squared, and you'll find those other 2 that sometimes we don't always remember. Okay. All right, look, let's scroll down a little bit and let's see if we can find a couple of things here. So y'all, let's do this. It says, the first example says we're going to find trig function values given 1 value in the quadrant. Okay, so y'all, before I get started, let's take a look and see what we got. Boom, right here. It's telling me that tangent of theta is equal to -5/3, and theta is in quadrant 2. Y'all, before I get started, I'm going to do this. Boom, boom. I'm going to do this. Boom, quadrant 2. Here we go. I'm in my second quadrant. Okay, let's see. Tangent of theta is -5/3. Y'all, when we define the tangent, how do we define it using y's and x's and r's and all that kind of stuff? Anyone remember? Tangent of theta, what is it defined as? Anyone remember? Y, x, r? Is it x over y? Is it opposite over adjacent, or is it adjacent over? Isn't it y over x, right? Look, y'all, so we're going to go like this, y over x. Okay, let me ask you a question. If we are in the second quadrant, y'all, which numbers are positive and which numbers are negative? Anyone remember? X is negative and y is what? Positive? So look, y'all, when I'm thinking about this here, look, I know that they gave me a negative 5/3. I know they gave that to me. But wouldn't we say that's a positive 5 and that has to be a negative 3? Because if I'm in my second quadrant, it's the x value that's negative. So look, we're going to go like this. Negative 3. It's supposed to be a negative 3. Positive 5. Okay. Y'all, let's see if we can find the r value. Okay. So look, I'm going to come back over here. Sorry. Let's come back over here. Let's go x squared plus y squared equals r squared. Okay, x negative 3 squared, y positive 5 squared, r squared. Negative 3, when you square it, what do we get? 9, okay. 5 squared, 25, r squared. Okay, 9 plus 25, isn't that 34? And so r is going to be equal to the square root of 34. Okay, guys, 34 is like 2 times 17. I can't really do a whole lot with it. Okay, so right now we won't. Let's come back and let's see if we can answer the parts A, B, and C. Okay, secant of theta. Y'all, isn't secant of theta defined as r over x? We just found our value of r to be the square root of 34. And we said our value of x was negative 3. Okay. Part B, sine of theta. Okay. Let's see if we can do sine of theta. Y'all, how do we define the sine of theta? Anybody remember? Y over r? Okay. Our y value, we already know, is positive 5. Our r value is the square root of 34. Remember, y'all, we're going to go ahead and rationalize our denominator by multiplying both the upstairs and downstairs by the square root of 34. So upstairs, we get 5 square roots of 34. Downstairs, we just get 34, right? Okay, let's look at part C. Part C says the cotangent of negative theta. Y'all, I want you to look at our notes. And in my notes, we have some things about even and odd functions or identities. Okay, look, y'all. It says the cotangent of negative theta is equal to the negative cotangent of theta. So I'm going to come back here and I'm going to say this is really the same thing as the negative of cotangent of theta. Y'all, we started off by saying that the sine of theta was negative 5/3. If the sine of theta is negative 5/3, what would the cotangent of theta look like? Isn't it just the reciprocal? Negative 3/5. But what's going to happen with this guy and that guy? Positive, right? Very good. They're going to cancel. Boom, positive 3/5. And you're done. That's all you got to do, right? All right, y'all, look, I'm going to scroll down a little bit further. Let's see. Okay, here we go. It says writing one trigonometric function in terms of another. So y'all, look what they're telling me here. They're telling me, can we write cosine of x in terms of tangent of x? Okay, so y'all, what they're asking us to do is can we use one of those identities? And the only other function we want to see, y'all, is tangent. We don't want to see sines. We don't want to see anything other than tangent. So y'all, I'm going to come back over here and I'm going to kind of look at some of the identities that we talked about. Y'all, this identity right here, this guy in the middle, I want to start off with that guy right there because I see tangent and I also see secant, and I know that I can change my secant to somewhat of a cosine, okay? So look, y'all, I'm going to come back over here and I'm going to say secant squared theta is 1 plus tangent squared theta. Okay. Let's see if we can do some things here. Y'all, we want to write cosine of x. If I see secant squared theta, couldn't I write that as 1 over cosine squared theta is equal to 1 plus tangent squared theta? Okay. Y'all, we're going to do a little cross multiplying. I want to try to write this thing in terms of a cosine. And right now I have a 1 over cosine. A couple things we can do, y'all. We can do cross multiply, or we can simply flip this guy and flip that guy. So look, if I flip this guy here, I'm going to end up with a 1 plus tangent squared theta. Okay. Now, y'all, we are trying to write cosine in terms of tangent. Right now, I have cosine squared. So I need to get rid of the square. Y'all, the way we're going to get rid of the square is we're going to take the square root. When we take the square root, y'all, we're going to write plus and minus on the other side, okay? So look, this square and that square root are going to go away. We're going to get cosine theta. Y'all, when we're taking the square root here, we can break up that square root as the square root of the top and the square root of the bottom. First question. Anybody know what's the square root of 1? Still 1, right? Okay. All right. Y'all, just like we've been doing before, we're going to go ahead and rationalize our denominator. I'm going to multiply both the top and the bottom by 1 plus tangent squared theta. Okay. Let's see. We're going to get plus or minus square root of 1 plus tangent squared theta. This square root and that square root, the square roots will just go away. And now we have written our cosine in terms simply of tangent. Y'all, the idea here behind the trig identities is to sort of hone the skill of being able to write one trig function in terms of another, okay? I know a lot of you said you're not going to calculus, right? But guys, this is pre-calculus, and the whole point of pre-calculus is to get you ready for calculus. Why they have you taking pre-cal if your major doesn't require you to take cal? You know what I mean? It's like, why would I take a pre-med class if I'm not going into med? Does that make sense, right? But that's kind of what the whole point of this stuff is here, okay? So that's why I'm kind of walking you through this process of showing you how to go from one form to another. Y'all, look, let's try a couple more that we got here in terms of 7.1, okay? So look what it's telling us to do here, y'all. It's telling us, can we write 1 plus cotangent squared theta in terms of sine theta and cosine theta, and then simplify the expression so that no quotients appear. Okay, so y'all, just so that you know, when they're talking about no quotients, they mean no fractions. Okay, it's just another word for fractions. Okay, y'all, let's do a couple of things here. I'm going to scroll up a little bit because what I want to try to do here, y'all, is use some of the identities like these guys right here. So let's do this. Okay. Okay. And all right, we're going to hold on to this because we're going to use it as we go through our stuff. Okay, so y'all, when they're telling me, can we write 1 plus cotangent squared theta over 1 minus cosecant squared theta in terms of only sine and cosine, the first thing I'm going to want to do, y'all, is change everything I can to either a sine or a cosine. So look, let's do this. 1 plus cotangent. Y'all, what I'm trying to do here is I'm trying to see, do I have any relationships or do I have any identities that involve cotangent. We do. We got two of them. Or we got a couple, but there's two of them. The first one I see is cotangent is 1 over tangent. The other one I see is cotangent is cosine over sine. This is the one I want to use. And you say, why do I want to use this one? Because they're telling me to write it in terms of sine and cosine. And this guy here is written in terms of sine and cosine. Does that make sense? Okay, so look, let's do this. Boom. Let's come back here. 1 plus, we said we could write this as cosine squared theta over sine squared theta. Okay. 1 minus, look, y'all, let's look at cosecant. Okay, I'm going to come back over here. Boom. Cosecant. Remember, I'm trying to write everything, y'all, in terms of sine and cosine. Well, my cosecant of theta is the same thing as 1 divided by the sine of theta. So why don't we do this? 1 divided by the sine of theta. Okay. Now, y'all, what we used here, when I'm thinking about something like this, like when I come back here, I said, look, the first one I used a quotient identity, right? And the second one I used a reciprocal identity. Okay, that's how I was able to get from one step to the next. Okay, so y'all, let's do this. Let's see if we can get some fractions together. Y'all, I'm going to think of that one as 1 over 1. And between 1 and sine squared theta, we could write this getting a common denominator of sine squared theta. We can say 1 is the same thing as sine squared theta over sine squared theta, right? Why? I want to get a single fraction upstairs. Okay. If I deal simply with my upstairs, y'all, on the bottom we have sine squared theta. Upstairs we have sine squared theta plus cosine squared theta. Okay. Let's deal with the bottom part of our fraction. Y'all, I'm going to think of that one also as 1 over 1. Okay. So look, why don't we write it like this? Sine theta over sine theta minus 1 over sine theta like this. And then here, y'all, we can write sine theta minus 1 over sine theta. Okay. All right, y'all, on the right side over there, that's what we call a complex fraction, because we have a fraction where both the numerator and the denominator are also fractions, right? Okay, y'all, remember what a complex fraction means. You're dividing, right? You're dividing fractions. How do we divide fractions? We multiply by the reciprocal. Okay, so I'm going to multiply by the flip of this guy here. All right, let's see what else we got. Okay, y'all, I'm going to go really slow here. First off, you're going to look at this guy right here. Sine squared theta plus cosine squared theta. Y'all, I'm going to pull up my identities again. Look, sine squared theta plus cosine squared theta is equal to 1. Boom. That guy is just going to go to 1. Okay. Let's try this, y'all. We can get rid of this sine theta with one of those, because on the bottom we got a sine squared, on the top we got a sine. So let's see, what else do we have here? We have a 1. Okay. Sine theta minus 1. Okay. Let's see. What else can we do here? Boom. Trying to see if there's anything else here, y'all, I can do. Oh, you know what? Y'all, I made a mistake. My bad. I didn't see this. That was my mistake, y'all. Look, 1 minus cosecant squared. You know what I wrote here? I didn't write cosecant squared. I wrote just sine. Do you see what I'm saying? That was a cosecant. That should have been sine. Okay, oops. Let's come back here. Let's fix the downstairs. Oops. It's okay. We had a happy little mistake. Okay, boom. Let's do this. Sorry about that, y'all. Okay, we're going to go like this, just like we did earlier. My bad, y'all. Sorry. Boom. We're going to get a common denominator again. Sine squared theta, sine squared theta, sine squared theta minus 1. Here we go. Okay. Okay. Sorry, y'all. I was writing, I just saw the cosecant, not the cosecant squared. All right. Oops. Let's put an oops right here. Okay. Now let's go ahead and flip what we got to flip. So first, again, just like I did earlier, y'all, come back here. Sine squared theta plus cosine squared theta over sine squared theta times, we're going to flip the bottom one. Okay. All right, here we go. Back again. Okay, this guy here, y'all, boom, that's just going to go to 1. Okay. This dude and that dude are going to cancel out because they're both sine squared thetas. Okay. So let's see. What are we left with? Upstairs, we got a 1. Downstairs, y'all, we got a sine squared theta minus 1. Okay. All right. Y'all, when I'm thinking about our Pythagorean identities, just to kind of show you something over here on the side, y'all, when we're thinking about those Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. Other things that we can think of in this terms of this same identity could also be things like sine squared theta is 1 minus cosine squared theta, and cosine squared theta is 1 minus sine squared theta. Okay. So I want you to look at this guy right here, and I want you to look at this guy right here. They're almost the same. The difference is here, the 1 is positive, and here the 1 is negative. Here the sign is negative, here the sign is positive. If we were to do this, y'all, then we would say, look, that's just a negative cosine. Okay. And negative cosine, y'all, we can write as a negative secant squared theta. Boom, and we're done. Okay. Y'all, when they're telling me to write things in terms of sine and cosine, and then they say, but make sure there's no quotients. If you end up with a 1 over cosine, it's okay for you to put a secant squared theta. Okay. Or if you end up with a 1 over sine, it's okay for you to write a cosecant, right? But that's kind of the idea here. And so again, we're trying to work from one side of the equation to get to the other. Okay. Y'all, the one thing I do want to mention about doing the identity stuff, which is what it is we're doing here, is it is a process and it takes time to figure out exactly how to kind of go through that process and break those numbers up. So y'all, this is what I want us to do for a little bit before we jump into 7.2. Okay. Let's try this. Okay, so y'all, this here is the homework for 7.1. What I would like for us to do is this. Look, let me try this real quick. Boom. Let's come back this way. Boom. Let's come over here. Let's do this. So let's do this. Okay, so y'all, what I want you to notice is if you look at your homework, on your question number 1, does it say the cosine of S is 1/3 and S is in quadrant 1? Okay, let's do this. Let's do this guy. And let's see if we can figure out how to find this. Okay, so look, we're going to do this. We're going to come back over here. Let's make it like that. Okay, y'all, what quadrant are we in? Quadrant 1. Okay, boom. Here's quadrant 1. There's my angle S. Okay, so look, y'all, how do we define the cosine of our angle? What letters do we use? Y, X, R. What is it? What letters do we use? Anyone know? X over R. Boom. X over R. Okay, so look, y'all, isn't my X equal to 2? And isn't my R equal to 3? And what we got to figure out is, hey, what's our Y going to be? Yes, ma'am. No. What I'm trying to do, I'm showing you what your homework looks like. We're going to do this one together so that when I do this one, when you do your homework, you're like, I know what to do because this one is real similar. See what I'm saying? Okay, good question. All right, so what I'm trying to do, y'all, is pull problems that are similar to what you're going to have. Again, the numbers are going to be different, right? But if I know how to do this one, then when I get to my homework and I do number 1, I'm just going to change a number here or there, right? Okay, so look, y'all, let's do this. Let's write out our formula for the Pythagorean theorem. X squared plus y squared equals r squared. Okay, so in our case, our x is 2 squared. We don't know what y is. We'll find that in a little bit. 3 squared. Okay, so let's do this. Let's see, that's 4 plus y squared equals 9. Y squared is equal to 5. Okay, y'all, we're going to have to take the square root here. What quadrant are we in? We're in quadrant 1. In quadrant 1, is the x value, so we're looking for the y value. Is the y value positive or negative? Positive. So we're going to use the positive square root of 5, right? Okay, look, we're going to go like this. Boom, there we go. Okay, y'all, we are trying to find, in this case, we're trying to find the sine of S. Isn't the sine of S y divided by r? What did we just get for y? Anyone know? Square root of 5, right? Boom. What was our value for r? Oops, sorry. And there we go. And we found the sine of our angle, right? And that's all I got to do. Does that make sense? That's really all I'm trying to do here, y'all. So look, let's try number 2. Again, I'm looking at your number 2, y'all. So look, let me come back this way. Boom. Your number 2 has what? -7 over 8? Okay. Look at the number 2 that we're going to do right now. Boom. We're going to come back this way. Okay. So again, y'all, what I'm trying to do is show you, like when you get to your homework, how do I do these problems? I'm doing problems that are similar, just have different numbers so that when you get to your homework, you're like, oh, I remember what Omar did. Okay, let's take a look, y'all. We got the cotangent of our angle is -5/6. We are in the 4th quadrant, y'all. So look, the first thing I'm going to do, boom, I'm going to come back over here. This right here, y'all, boom, there's quadrant 4, right? Here's my angle. Okay, let's do this for a minute, y'all. Cotangent of my angle, using x's and y's and r's and all that kind of fun stuff. How do we define the cotangent of our angle? Anyone remember? X over y? Good. X over y. Okay, let me ask you a question. In quadrant 4, which coordinates are positive and which coordinates are negative? Anyone know? X is positive, y is negative. Okay, so look, y'all, see how they're telling me this is a -5/6? Why don't we think about that as a 5 over a -6, right? Because we know that the x value is going to be positive, +5, and we know the y value is going to be -6. Y'all, what we need to do, my friends, we need to find the value of r. Okay. So look, let's do that. Let's see, x 5 squared plus y negative 6 squared equals r squared. Okay, 5 squared, 25. Okay, negative 6 when you square it. What's negative 6 times negative 6? 36, still good. Okay, r squared. All right, 25 and 36. Y'all, is that like 61? Okay, r squared. Y'all, remember, my r is always going to be positive, right? The x values, the y values, those could be negative, but the r always going to be positive, okay? So we got our r to be square root of 61. All right, we found that. Now, what is it that we're looking for? We're looking for the sine of our angle. Isn't the sine of our angle defined as y over r? What did we say our y value was again? Anyone know? So we look over here. Y was which one? Negative 6, right? Boom. Okay, r is square root of 61. Y'all, let's go ahead and rationalize that. Okay. So take a look. We're going to get negative 6 square roots of 61 over 61, right? And that's how I'm going to find each of my angles, right? Each of those functions that they're asking me to find. Look, y'all, if you're wondering like, hey, Omar, how do I know you're telling me the truth here? Boom, negative 6 square root 61 all over 61. Let's check our answer. Boom, I would have been real embarrassed if I would have said it was wrong, right? Boom, but it was right, okay? But that's what I'm trying to do here, okay, y'all? So look, let's do a couple other ones. Again, I want to give you guys some practice with some of this stuff here. Ooh, let's try number 4. Boom. So again, y'all, I'm going to go through some of these questions again to give you some practice on how we can figure things out. Okay, so y'all, I'm looking at my number 4 here, and I see your number 4 similar, but not exactly the same. But that's okay. It's close enough. Okay. Couple of things we know here, y'all. They're telling me right now at the beginning of this thing that the tangent of my angle is a positive or a negative number. What do you think? What does it look like? It's negative, right? Okay, so tangent is negative. So look, y'all, let's do this just so that we know what we're talking about. The tangent of our angle is negative. They're also telling me the cosine of my angle is positive. What we got to figure out, what quadrant would I be in if the tangent is negative, but the cosine is positive? So y'all, I want you to think about a couple of things. Don't we define the tangent of our angle as y over x? And don't we define the cosine of our angle as x over r? Okay, so look what they're telling me. The cosine is positive. Y'all remember, my r value is always going to be positive. But if the cosine of my angle is positive, then that means the x value has to be positive. Y'all, if the x value is positive, wouldn't that tell me that the y value would have to be negative if the tangent is a negative number? Okay, so my question to you, what quadrant would we be in if my x value is positive and my y value is negative? 4. Boom. Let's draw our angle. Here we go. Boom. Here we go. Okay, there we go, y'all. So let's take a look here. When we're going to do that, and we're saying that the tangent of our theta, which we define as y over x, we're going to say that the y is the negative square root of 10 and the x is 3. Let's see number 1, y'all. Can we find my r value? Okay. Let's see. Let's go through it and let's see what works out here. Okay, x is going to be 3 squared, negative square root of 10 squared, is equal to r squared. Okay. So let's do this. Look, let's see. 3 squared is 9. Remember, a negative, when you square it, it's going to become positive. Squaring the square root goes away. That's just going to be 10 equals r squared. So r squared is 19. So r would have to be the square root of 19. All right. What are we trying to find? The directions are telling me, can we find the sine of our angle? Okay. Sine is equal to y divided by r. We said our y value was the negative square root of 10. Our r value is square root of 19. Boom. And there's my sine of my angle. Is this working? Are we doing okay so far? Yeah? Okay, just check one of you guys here. All right. Let's try another one, y'all. Okay, let me do this, y'all. Okay, let's come back over here. Okay. All right, so y'all, I'm looking at a number 11. It's on the second page of your homework. And if you look at number 11, let's see, number 11, let's make sure. Boom, here's, looks a little different. Maybe number 10. Let's do number 10. I'm going to do my number 10 here because it looks, let's see, is it the same thing as your? No, but it's kind of similar. Let's do this. Okay. All right, and let's see if we can't figure out what it is they're asking us to do here. Okay, we want to write the expression in terms of sine and cosine and simplify so that no quotients appear in the final expression and all functions are of theta only. Okay, so look, y'all, if we're going to write everything in terms of sine and cosine, let's start off with this guy right here. How could we write cotangent in terms of sine and cosine? Anyone know? Yeah, so look, y'all, this is what we're going to do. Boom, we're going to come back up here, and we're going to look at our identities, and we're going to say, look, cotangent is cosine over sine. Okay, so the first thing we're going to do, we're going to write, cosine theta over sine theta. Okay. All right, boom. Over here, y'all, right here, boom. Sine theta. I'm not going to mess with that guy, y'all, because the directions are telling me write everything in terms of sine and cosine. It's already a sine, okay? Let's mess with this one right here, secant. What's another way we can write secant using either sines or cosines? Anyone know? Look, we're going to come back over here. Boom. 1 over cosine. Very good. We're going to come back over here. Boom. 1 over cosine of theta. Okay, y'all, is anything on the top going to cancel with anything on the bottom? What do you think is going to cancel? The sines? Boom. What else is going to cancel? Anything else? Y'all need some help? Ladies? Do we need some help? Huh? Are you sure? Do we need help? I'm going to ask you to do me a favor. I'm going to ask you to sit over here next to Cole for a little bit and do me a favor. Don't bug Cole. Okay, boom, there we go. All right, guys, what did we end up with here? What did we end up with? If all this stuff cancel out, what do we still got? 1. There you go. Y'all, the idea here in these problems is that, so look, y'all, I want to show you guys something. Look, I'm going to come back over here. Boom, I'm going to come back here. I'm going to write the number 1. I'm going to check it. Okay. So y'all, what I'm trying to point out here in these problems is that you have to be able to justify, how did I get from one step to the next? What is it that I did from one step to the next? And I have to be able to see what did he do, right? So y'all, one thing I'm going to recommend is as you're doing this here, let's figure out which of the identities we're using to get from one step to the next, okay? So look, let's see if we can try another one kind of similar. Oh, let me try, y'all. I'm going to kind of move down here. Let's see. I don't know why. I thought there was more. Let me do this. Boom. Let me do this. Boom. Do this. Boom. Here we go. Okay, so y'all, I'm looking at this question here in my list, and it looks really, 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 really similar to one of the questions that you guys have in your homework. Okay, so look, let's come back over here. Y'all, I'm looking at this question, and in your homework, this kind of looks a little bit like number 13. Okay, so look what it says. Write the expression in terms of sine and cosine, and again, simplify so that no quotients appear in the final expression. Okay, so the first thing I'm going to do here, y'all, we're going to write everything in terms of sine and cosine. Okay, so if we already have sines and cosines, y'all, I'm not really going to do much with them right now. But if I have something other than sines and cosines, I want to see if we can fix those things. So look, let's try this. Negative cosine squared theta, okay? And y'all, I'm going to come back over here and I'm going to look at some of my identities here, okay? I want to see if I can use some of these identities in my problem. Okay, let's take a look what we got, y'all. If I look at the problem, I have a 1 minus secant squared theta. A 1 minus secant squared theta. Okay, y'all, if you look at this guy, if I look at this guy right here, okay, and I'm going to write it over here on the side where I got a little bit of room, okay? So the identity that we have is tangent squared theta plus 1 equals secant squared theta, okay? And so, y'all, the reason why I'm thinking about this guy right now simply is because I see like a 1 minus secant squared, okay? So I might think of something like this. I might think of, look, isn't tangent squared theta the same thing as secant squared theta minus 1, right? Okay, but when I look at this guy, it's not 1 minus, it's supposed to be secant squared theta minus 1. And what I have here is 1 minus secant squared theta. So if I put a negative in front, then that makes it flip around, right? So we could say 1 minus secant squared theta is the same thing as tangent squared theta. And you might say, why do you want to write tangent squared theta? I'm going to tell you right now, y'all. Can we write tangent in terms of sines and cosines? Should it be a negative here? Couldn't we write tangent, y'all, as negative sine squared theta over cosine squared theta? Okay. All right. So what did I use here? I used a Pythagorean identity. What did I use here? I used a quotient identity, okay? All right, what's gonna happen? The cosines are gonna go away. A negative and a negative is a positive. And all I have left, y'all, is the sine squared theta, right? And if I come back over here, y'all, and I look and I say, hey, is one of my choices a sine squared theta? Say, yeah, it looks like D. Let's check it. Boom, right? I would have been real embarrassed if we would have gotten it wrong, right? But again, the idea here, y'all, is when you're doing your homework, right, and you're looking at your number 13, you know, you can always look in the back and you can say, hey, you know what? The number for 13 is E. How did you get there? The biggest thing in the identities, y'all, is you got to show from one step to the next how you get there, right? And so with the identity stuff, y'all, and again, I'm telling you this because with the identities, you have to be able to justify each step, okay? There is a process in how you get from one step to the next. So look, let's do this, y'all. Boom, let's come back over here. let's start 7.2, okay? And again, y'all, what we're going to do here in 7.2, and I have the homework and I also have another handout, kind of like what we were doing here. So I'm going to give you the homework and then we're going to work a couple of questions to see how do we get from one step to the next. All right, y'all, for 7.2, when we're verifying trig identities, it says we're going to learn something we call the fundamental identities, okay? So when I'm thinking about those fundamental identities, y'all, I'm thinking about these identities. Let me come back here so that we can kind of reference them. These are the fundamental identities, okay? So look, let's do this, boom. Let's do this, boom. Let's take a new screenshot. This is what I'm going to be using, y'all, in 7.2, okay? So I'm going to have that as a reference so that we can kind of go through what we're trying to figure out here. So it's telling me, hey, make sure that you can use one of these, okay? Make sure you know these here. Do you have to memorize them? No, but just have them as a reference, okay? And y'all, I will bring you guys like a handout on Wednesday that has some more identity stuff in there. Okay, look what it says. Try to rewrite the more complicated side of the equation so it's identical to the simpler side. It's sometimes helpful to express all trig functions in terms of sines and cosines and then simplify the answer. And then, make sure you know a little bit of algebra so we can kind of figure out what it is we got to do, okay? All right, so let's just start with this side here, okay? All right, so y'all, what I'm going to do here, we're going to verify our identity. And it says working with one side. Okay, y'all, they're telling me that we should work with the more complicated side, okay? So y'all, when I'm doing something like this, I'm going to decide on my own which side do I want to work with. I'm going to say that this is the one that's more complicated just because it has more pieces, okay? So y'all, this is what I'm going to do. I'm going to write step number 1. Everything here, we're going to try to write it in terms of sines and cosines. So when I see a cosecant of theta, y'all, I want you to look at what we have up here. When I see a cosecant of theta, boom, I'm going to rewrite it as a 1 over sine theta. Okay, so my first step is I'm going to do this. I'm going to write 1 over sine theta, cosine theta, plus sine theta. Okay, y'all, right next to it, I'm going to say, what did I use? So when I come back over here, see how this says reciprocal identities? Y'all, I'm going to keep this easy. I'm going to go Ri. That was a reciprocal identity. Okay. Number 2. Okay. Y'all, I'm going to multiply. Okay. We're going to multiply. So we're going to take this dude right here. We're going to go once. We're going to go twice. So we're going to say cosine theta over sine theta plus sine theta over cosine theta. Okay, what did we do? We're going to keep it simple. We multiply. Okay. Step number 3. Y'all remember what it is I'm trying to get to. I'm trying to get, just so we know what it is we're trying to get to. I'm trying to make this side of the equation look like that side of the equation. Okay, the first thing I see here is a cosine over sine, okay? And when I look at the left side, y'all, I see a cotangent of theta, okay? So look, y'all, cosine over sine, the way I can write it into a cotangent of theta, isn't that using a quotient identity? So right here, I'm going to put cotangent of theta plus 1. What did we use? We used a quotient identity. And we got the right side to look like the left side. When you're doing this in your homework, you got to have to justify each step. And each one of those steps has to be justified with the right identity, right? So we said, I used the Pythagorean identity. And I say, okay, hold on. Pythagorean identity is like the sine squared plus cosine squared theta is equal to 1. And nothing here is squared. How'd you do that? And you'd be like, oh, I don't know. Okay, you got to make sure you can justify each step. And the way we're going to justify those steps, y'all, boom, is being able to justify using one of those identities that we got right there. Okay. So that's how the homework in 7.2 is going to be set up, y'all. There, when you say like, okay, when you're doing something like this, there's no necessarily like, what's the answer? The work that we did right here, that is the actual answer. How did you get from one step to the next? So that's why I'm kind of trying to go really slow and make sure that we know how we got from one part to the next part, okay? Look, let's try another one. Okay, we're going to verify working again with one side. Okay, so look what we got, y'all. We're going to verify that the following equation is an identity. So we have tangent squared x times 1 plus cotangent squared x is equal to 1 minus, or 1 over 1 minus sine squared x. Okay, y'all, I'm going to do the same thing here. I'm going to work with the more complicated side. And that side there looks like it's a little bit more complicated. Okay, so my step number one, y'all, okay, my step number one, is I'm going to try writing things in terms of sines and cosines, okay? So look, y'all, I'm going to say sine squared x over cosine squared x, 1 plus cosine squared x over sine squared x. Okay, now I'm going to say, how was I able to do that? I'm going to come back over here. If I went from tangent into sines and cotangents, I'm using a quotient identity. Boom. Let's come back right here. Quotient identity. Okay. All righty. Let's try this, y'all. Let's try doing some multiplying. Let's take this guy here. Let's go once. Let's go twice. Okay. So we're going to have sine squared x over cosine squared x plus sine squared x cosine squared x cosine squared x sine squared x. All we did is multiply. Okay. Number 3. Okay. These guys are all going to cancel. We got sine squared x. Oops. Not sine 2x, Omar, but sine squared x. Okay. Because canceled. I think there's 2 L's that cancel. Boom. There we go. All right, y'all, let's see if we can do something here. Let's see if we can do some algebra and get a common denominator with those guys there. Okay. So I'm going to do this. Boom. Okay. Let's do it this way. Sine squared x cosine squared x plus cosine squared x cosine squared x. Okay. Okay, that's just algebra. Okay, boom. Next step, sine squared x plus cosine squared x. Okay, boom, boom. More algebra. Okay. All right. Does anybody remember what's sine squared x plus cosine squared x? I'll give you a hint. 1. Boom. Right, here we go. It's equal to 1. Boom. Thank you, sir. 1 over cosine squared x. Okay, that is Pythagorean identity. Okay. All right, look at what we're trying to get, y'all. Right now I got 1 over cosine squared x. What do we have on the other side? We got a 1 minus sine squared x, right? Okay. Y'all, remember when we said, oops, sorry. Remember when we said sine squared x plus cosine squared x is equal to 1, but we can also say things like cosine squared x is 1 minus sine squared x. It's just another version of that. That's what we're going to do right here. We're going to say this is 1 minus sine squared x And again, that is another Pythagorean identity, right? And if you notice, what we have on this side, y'all, is that piece right there, right? So again, the whole point, y'all, of doing this kind of stuff here is, yes, I can make it look like the other side. How? What are the steps involved in getting there? Okay. So again, y'all, what the point that I'm trying to make here, and I hope I'm not being too repetitive, but these are the steps with their justifications that we're looking at. That's what I'm looking at, right? So how do you get, we already know what the answer is. We know that the left side is equal to the right side. How? That's what we're trying to do in these kind of problems here, okay? Look, y'all, let's try one more, and then I'll give you the homework for 7-2. And then when we come back on Wednesday, I'll kind of show you, don't have, I mean, I'll give it to you today, but I'll show you what we're going to do on Wednesday, okay? All right, let's do the same thing here, y'all. Again, we're going to verify that this thing here is an identity. All right, let's see. So, y'all, we got to pick a side that we're going to work with. Oh, my goodness. Y'all, I think I'm going to go ahead and stick with the left side because I think the left side has more complicated things. Okay. So, y'all, when I'm working with this side right, oops, sorry. When I'm working with this side right here, my first step initially, what I'm thinking of is one of the things it tells us to do is write things in terms of sines and cosines. Y'all, if you look upstairs, I have tangent and cotangent. How can I write tangent and cotangent in terms of sines and cosines? Anyone know? Let's come back here. Let's take a look. Boom. Tangent. Look, y'all, we can write tangent as sine over cosine, and cotangent, we can write it as cosine over sine. So we're going to say sine t over cosine t minus cosine t over sine t. And on the bottom, I got a sine t cosine t. Boom. What did we use? That was a quotient identity, right? Yes, quotient identity. Boom, there we go. Okay. All right, y'all, let's do this. Let's get these folks together by getting a common denominator, okay? So, y'all, between cosine and sine, my common denominator, y'all, is going to be cosine t and sine t. Okay, y'all. Now I'm going to ask you to do me a favor here. I'm looking at this guy right here, and I'm looking at this bottom. Look at this bottom. What do I have here that I didn't have before? Anyone know? What do we have right here that we didn't have the first time? The sine? Does that make sense? Did I lose you guys, or are we okay? We're good? Okay. Look, y'all, there's a cosine, there's a cosine. Okay, so look, we're going to go, we put a sine t there. We got to put it as sine t. Okay, look, y'all, that's a sine squared t. Okay. All right, let's do the same thing here. Look, let's look at this side right here and this side right here. What do I have down here that I didn't have the first time? The cosine t? So we're going to put a cosine t as well. Okay, cosine squared t. All right. Now, let's do this. Boom. Remember, on the downstairs, y'all, we still had a sine t and a cosine t. Okay. What do we do here? That's just algebra. We're getting our common denominators. Okay. All right. Sorry. I'm going to zoom out here. Okay. Let's do this. Now that we have a common denominator right here, y'all, let's write it as a single fraction. Sine squared t minus cosine squared t over cosine t sine t divided by sine t cosine t. Again, we just a little bit of algebra, right? We had our common denominators. We put it as a single fraction. Now, remember, y'all, we need to go through and manipulate a couple of things. So remember, we're going to take, since we got a complex fraction here, y'all, we're going to fix this. We got a sine squared t minus cosine squared t over cosine t sine t times 1 over sine t cosine t. Okay. Again, that's just a reciprocal. Okay. And now I'm going to multiply, y'all. So I got a sine squared t minus cosine squared t. Let's see, we're putting these guys together. Y'all, we're just multiplying. So look, sine and sine, sine squared t, cosine squared t. Okay, I've seen this, and I'm trying to see, what am I trying to get at? Okay, what am I trying to get at? Let me come back to the original problem, y'all. Look, y'all, in my original problem, we're trying to get to a secant squared theta minus a cosecant squared theta, okay? Y'all, I'm going to go ahead and separate my fraction again, okay? I know we just combine it, but I'm going to go ahead and separate my fraction again. Sine squared t over sine squared t cosine squared t minus cosine squared t over sine squared t cosine squared t. All right. Now, the reason I'm doing that, y'all, those guys are going to cancel. Boom, those guys are going to cancel. We got 1 over cosine squared t minus 1 over sine t. Okay, so here, separate, here, cancel. All right, let's take a look, y'all. Is there a way, what's another way we can write 1 over cosine? Secant squared t. What's another way we can write 1 over sine? Cosecant squared t. What did we use to do that? Oh, those look like reciprocal identities. And if I look at this side here, y'all, I know it's a lot of work. Boom. That's what I'm getting on that side over there. Okay. Y'all, the point of the trig identity stuff, again, is to justify how do you get from one step to the other? Can you manipulate one side so that it looks like the other side, okay? Let me show, I know we still got another problem there, and we might hold off on Tuesday, okay? But this is what we're going to do. We probably will hold off to it on Tuesday. Okay, so guys, if you notice what I just handed out to you, I handed you the homework for 7.2, but then if you also see the other hand that I gave you guys is an in-class practice. When we come back on Wednesday, let's do this real quick. Boom. Let's do this. Okay, boom. Let's stop recording. Okay, and guys, I'll